Hi again, I'm Konrad. Today I'm going to speak about Jenkins. Actually, this is not about Jenkins, surprisingly. This is more how we managed to survive in the world of changing requirements. So let's begin. And let's begin with some random set of thoughts, which will lead us somewhere. So, stating the obvious. Open source projects are handled not the same way the commercial projects are. So when you are managing your open source community, you have to take into account different aspects of that. So for example, in open source projects, usually you have a very different person to commit ratio. In open source, person comes, thinks, okay, I have an issue, and goes away. Or, okay, I have a feature, here's a pull request, and he goes away, disappears forever. Sometimes. In commercial projects, it's slightly different, and we can at least count on the people, usually, who write the code. So this leads us to a different trade-off. In open source projects, we need to put emphasis on the CI server the most. The code needs to be super reliable out of itself. Or at least let's have some benevolent dictator for life, like Python has Guido, Linux has Linus, etc. But it's somewhat differently looking in commercial projects. Because for commercial projects, well, why you do them? Because you earn money. That's normal stuff. But in return, business needs to get money too. Which means that business projects need to be adaptive, because it is not possible in reality to close yourself in a basement, code for half a year, and come up, hey, this is the perfect feature I was implementing for half a year. As we probably saw around 80s and 90s, the waterfall approach, the basement approach, doesn't work out very well in practice. Contrary to that, the Agile Manifesto was created. One of the ways to achieve agility is to have evolutionary, iterative approach. So iterative approach is mostly about having a good ratio of features implemented in time, because we can assume that 20% of features will cover 80% of use cases. But it's also about code dev management. When you have a high pressure in your project, you need to, okay, implement more features, possibly with more code smells. The bad code. Nobody wants bad code, but unfortunately in practice this is inevitable. And then, of course, because we are iterating, we need to find in maybe another iteration a good balance between, okay, let's fix the bad code for let's implement new features. So iterative evolutionary approach is all about picking the right choices at the right time. Of course, nobody's perfect. Some mistakes will be done here, but usually this works quite well. So let's talk about projects from the perspective of Jenkins. This is actually a story of our project where we use Jenkins, of course. How we managed to evolve our solution without rewriting it from scratch, without rewriting. This is often claimed to be the solution panacea for all problems, but it mostly is not. And there are cases, for example, of the Netscape. Netscape nearly lost all of the customers because it's okay, let's rewrite the browser from scratch. And that's when Internet Explorer won. So without rewriting everything, we managed to survive and adapt to more and more requirements. So this is going to be a story without any chronological order, with just an order of it was easier to present right now this way. So overall the agenda, I'll show you the most trivial Jenkins. I'll discuss the most obvious problems with that. And then I'll show you 4 quite powerful ideas that we've implemented. And of course, it's evolution. We never end with improvements, so I'll lay some ground for future work discussing them. But let's start with basics. Let's start with trivial Jenkins. We have the repo, in our case it is Git. We have Jenkins, and we have AWS. For this case, let's assume that we're starting small. A new team, maybe only developers, and one of the developers was given a task, okay, you will be the DevOpsy kind of guy. Please do something so our code at least deploys to proof of concept environment. Nothing biggie, just do that. So what should that person do? He or she should do the least effort, actually. So assuming simplified use case, we have build and test, which is used for continuous integration. And we have another job called build and deploy. So on every step, Jenkins will, on some occasion, like manual click or on cron, take the sources of the application, perform some logic that is embedded into Jenkins, and then put onto Elastic Beanstalk in this case, on AWS or any other cloud or server. So this is super easy and super quick to set up. This is like probably the most trivial setup imaginable. And actually it does the job pretty well. I know it's nothing fancy, no abstractions, no pretty code, but this is exactly how projects should begin. We can already identify some problems though, and those problems will bite in the future. But don't worry, let's not too eagerly solve problems that do not yet exist. So first problem is that we have a script application. Conceptually, okay, deployment to cloud is probably super easy. It's like one-liner or two-liners, like AWS, Elastic Beanstalk, something. Build is also super simple and pretty quick because we have a small application, so it's Maven clean install and something. And we get jars, no biggie. But then comes the reality, and your proof of concept application, okay, it's more successful. Great. So as a single DevOps engineer, let's say, I would be able to effortlessly handle, let's say, 3 to 10 such jobs. Sure, it's duplication. And it's kind of error prone, and it's tedious, and it's actually no fun, but it delivers the code today. It's not like I will implement some super fancy solution and bring it tomorrow. No, the business already has some value already. However, well, because the proof of concept was pretty successful, now we're going to deploy to stage. And stage should be similar to production, and production will come shortly afterwards. So with some assumptions, let's say that with that approach, with the super simple Jenkins, we will have 3 times the number of jobs, because for every different deployed environment, we'll have different deploy job. So that's not good. Oh, sorry. So that's not good. So at around 30 jobs, it's okay. It starts getting super error prone and super tedious, and maybe let's start thinking about something better. And then because it was all successful, we managed to do everything well. Then someone comes and says, "All right, so now you have more jobs. I'll put more projects for you, but no, please don't. I have too many things already. All right, so let's expand the team." And this is really starting to get bad, because teams bigger than one person needs communication. And communication often is assumed to be effortless, zero cost. It's not the case. With one person, you don't need to handle tickets on Jira. You have everything in your mind. Maybe some notes, to-do notes, whatever will work actually. With 2 people, all right, you need some synchronization. It's best if you work in the collocated space. With 3 people, all right, more will come, but we can manage. With 5, things are getting more and more complex. And I'll guarantee that someone will sometime and in the future forget about, oh yeah, that there was this slight detail that is very important, and yes, that broke the production. And believe me, that happens. Really trivial issues like during deployment, someone changed the way the Jenkins job works, and this is super obvious, but when you're doing the deployment, that's not the best time to learn about that, isn't it? So, but we managed to handle all of that. So we're going to get even more projects because we are a successful team, right? And then we'll handle more fun applications, and those applications no longer have any easy kind of deployments. Even the build system probably is getting complex or even time-consuming. I remember once, many years ago, I was working with an application that was taking 40 minutes to compile. I thought it was long, but then I got even longer times. So how to manage all of that in the future? Well, evolve. So the evolution. The first step, or one idea that we got as a part of the evolution, is as follows. Let's say that our biggest issue, maybe, is that Jenkins has all of the ideas. All the logic about building and deploying is in the Jenkins itself, which means, in return, that if we have many environments, we have many times the code duplicated. How can we tackle that? Well, the solution is somewhat easy. We can put the logic into Git itself. So how does it work? As usual, when you want to build and test, you run the Jenkins. The Jenkins will, and here's the unusual part, because usually Jenkins will, all right, grab the code and run Maven and some other stuff. In this case, Jenkins will sure get sources from Git, but then it will no longer build Maven. It will no longer do any other stuff that it should know. Instead, it knows from this point on one thing. There's a script called build. Execute it. If we do that, the Jenkins starts to be pretty silly. It doesn't know about the implementation details, and this is great because every piece of logic is in the repo. It can change, and Jenkins doesn't need to be modified, which makes Jenkins even simpler to manage. But the biggest, in my opinion, the biggest impact this has is that if you have a complex logic to build, deploy, or do any other stuff, now it's in the Git. And that enables us to do code reviews. In other words, you're no longer discovering things that change to your system because your teammate told you so. You no longer discover that because something broke when you were trying to do some kind of deployments. No, you can just read a history of Git or just follow pull requests on your projects. That is really, really great. Of course, we have all other improvements, like because we have logic in the repo, we can roll back if we make mistakes. This is really, really easy, but has probably one of the biggest impacts for maintainability. Still, this is not too good enough. First of all, as you probably noticed, we have built many times. So if we want to test, we will build. If we want to deploy, we will build. If we have quick builds, that's all right, no biggie. Sure, it could be easier, but this is actually a problem, especially as the project evolves and project gets bigger. Let's leave that for a bit later and stick with this approach. There's another problem, though, the synchronization of the Jenkins and scripts. Think of it as a kind of a protocol, because in disguise, it is a protocol. So we have a Jenkins, and Jenkins represents a kind of the global state. So Jenkins is single. It's there. It's doing code deploys. It's getting code, pushing code, whatever. However, the code on the repo is very local. If you build from a feature branch, it could have potentially, I don't know, Gradle instead of Maven. Jenkins doesn't have to know, but there's some parts that need to be passed. For example, I don't know, during deployment, maybe you need to pass subnet name or IAM role name to assume, or any other stuff that needs to be passed, no matter the implementation details, but it needs to be given in the script, which gives us the protocol. It could be a scary thought that we have local state and global state, because, oh no, that's going to hurt us, doesn't it? But, well, we were scared of that. And our experience says, yes, this could bite. But again, 80-20 approach works here really well. We coded very simple checks. So on the side of this script, we just put, all right, if you didn't get this environment variable from Jenkins, just return error. And, you know, this is really good enough for 80% of cases and allows you to quickly move forward. So, but remember, we're starting to dealing with kind of protocol-based approach, which is still pretty fine. Nevertheless, and this is the second idea, nevertheless, the problem. We have some knowledge about the scripts in the repo, but then how to execute them. All right, this is going to be on the Jenkins. Sometimes you want to be a bit more elaborate, or, I don't know, set some shell params to always return error from the shell when there's any kind of error, or maybe even pipe fail option for shell, or any other detail. You need to apply that everywhere in each job. Oh, and by the way, we're probably at the point where we have 30 or 40 jobs already on Jenkins, so that's starting to get out of the hands. So what can we do? Well, the first approach would be to codify those jobs, and that's super easy. So let's put logic about what Jenkins contains into repo itself. There are at least two good plugins for that. The first one is JobDSL, the second one is pipelines. Pipelines is probably the most natural for some. Many of you probably know the Travis CI or Circle CI open source, well, projects that give you open source, your open source project's ability to be built. And pipelines is very simple. You put code that is form of a YAML file or something like that in the repo, and Jenkins, when it says, okay, let's build that, Jenkins will read this file, execute every step there, and do it. Sure, that works. However, we found out that for our approach and our requirements, JobDSL is probably a better approach. JobDSL is kind of the different beast. In reality, the implementation detail of the Jenkins is that it doesn't have any kind of database. It always operates on config XML files. So when it runs a job, it opens the config XML of the job, reads what should be there, okay, and let's execute that. So some guys had a really clever idea. Modifying XML files is, oh, that's not good. Also, modifying Jenkins jobs by hand is not good. So let's write a simple DSL in Groovy to generate that XML, make it pretty and manageable, and that's it. Yes, that's JobDSL. We like it, so we are really content of JobDSL right now. So essentially, this allows us to keep in Git the description of the jobs, what they should do, description of the Jenkins, what it should do from different perspective. And because we keep them on the same branch, there's less of the problem of synchronization, which is not kind of true. allow me to explain. So let's say you have this job that deploys the code to your Elastic Beanstalk environment, and you have a set of parameters there. And you have the set of parameters described in JobDSL, and that is applied to Jenkins. So what if you start working on the feature branch that removes one of the parameter there and adds another one? Okay, so now from this feature branch, you need to take the description of Jenkins, apply this description to the Jenkins that is a global state, and start deploying your application. This is okay for a single person development, but for a team, well, kind of problematic. Okay, not really. So here's another insight from our project. We found out that this sounds scary, but it is actually not quite. This is easily manageable because first, the protocol rarely changes. Really, when you make it work, usually you will be adding more parameters, which is backward compatible. You will be doing some other stuff, but breakage of the protocol happens very rarely. And even in that case, this is super simple for anyone to go to Slack and, hey, channel, watch out, I was seeding the Jenkins. As simple as that, 80-20 approach. This is 20% of effort and gives you 80% of benefits. So, well, we still have this built in every task. So, let's try to tackle this one. So, let's split the Jenkins jobs slightly more. So, let's have a build job that is slightly different from the others, and other jobs. So, build, of course, it will take app sources because it needs something. Also, as previously, it will take scripts because it to just know how to build those. But then something weird happens. In our case, for 2S3 and Artifactory, but doesn't matter. The idea is take the generated application, the jar file, take all of the scripts, all of them, bundle them together and put into your persistence. From this point on, whether you want to test your new artifact that contains both thingies, you will talk about a single artifact. No longer you talk to the repo. This is really nice because it allows for, first and foremost, more reproducible setup. If you have a jar file, and well, this is a battle story, sometimes you want to develop a new feature for your application, and that feature will require some additional resources on AWS, on any cloud provider. So you will provide those changes in both scripts, so they will, for example, during deployment, set up something else, like, I don't know, EBS volumes, and you will use those features in your code on the Java side. So with approach of having this, well, this is an inherent problem. Jenkins is a global state here, and there could be a way, there could be an occasion where Jenkins has old code of itself, and you sometimes want to deploy new code. Well, this could happen. It doesn't usually. Don't worry about that. It sounds scary, but if you just have implemented the most basic setup, like if you haven't provided this environment variable, break with error and break early, like 5 seconds after clicking start. This is enough to tackle that situation. And the code error will be so obvious that you'll spend very little time on that. And yeah, that works really, really nice. You bundle stuff together. You start thinking of the artifact as a set, a pair of application and scripts, and now they live together through the rest of their lives. we found it to be really good abstraction. And by the way, in theory, it could, well, there are two approaches to this bundling. First approach is to essentially take the scripts and any kind of config and any kind of that stuff and put into jar file. The other approach is to have just leave them together. Like jar could be named abc.jar, and scripts could be called abc.scripts or .zip. The second approach works for us in our case with the intent that it could happen that you would like to run the newer jar with different version of scripts, and that never happened. Oh well. But, well, we have this ability up to this day, but this is really not required. If that situation happens, usually something more complex is going on, and usually just rebuilding with different branch is good enough. Or merging some codes, fully manageable. And here's the last piece of the puzzle, the pretty and full power jobs. So in this approach, all of those jobs have whole power. And that is both good and bad. So first of all, how do you like to do deployment? Well, personally, I like to click one button and do not input anything else. I will promise you that no matter how careful you will be, you will make a mistake. You will be surprised how many times we found out that there are parts of Jenkins UI that put white space, invisible white space inside, and so copy-pasting doesn't work too well. Or you misclicked and confused two fields. So this is field A, this is field B, but you put the parameters in the order B and A, and other stuff like that. I don't like to have too much power, because that makes my life more complex and allows me to make mistakes. I don't like to make mistakes. So the idea is, okay, let's create a second set of jobs. Those jobs are named similarly to Python convention. Python convention with underscores means essentially like this. Okay, it's kind of private. You can look into it if you know what you're doing. If you know what you're doing, you're on your own, you'll handle that. So that is actually what we want here. So in our case, we do it the following. So when you want to run the build job has very little parameters. Even it has nice combo boxes that talk with Bitbucket and just get a list of all branches to present to the user. So you just select, okay, this branch I want to build. And this build job, this nice and pretty, the fancy job, will actually call the underlying job. The underlying job has many more params to give. For example, should I run Maven tests? What parameters to Maven should I pass? Other stuff like that. This kind of parameters is not quite the set, the part of the build script, because build script will just execute Maven, probably do some other stuff. But this is the parameter. Do you want to build jobs? Tasks. Do you want to build tests? Once in a while, you want to really quickly build the artifact or iterate quickly on the code or scripts and don't want to run tests at that point. So it's useful. Other jobs follow the same convention. The test and deploy. Deploy will, for example, deployment to production will have just, okay, select this artifact, again, some fancy combo boxes, and click deploy. Nothing else. But under the hood, it will call the job that takes a lot of parameters, like the VPC ID, the subnet ID, the IAM roles, etc., etc. They are all parameters because for provisioning, we want to have the ability to deploy to to various environments. So this should be the parameter. Sure enough, you have to manage those parameters. So you have to manage those parameters. But since we have codified Jenkins and every job on Jenkins is written already in pipelines or JobDSL, this is no longer a problem because, well, use your invention. This is groovy. You can write any kind of abstractions that that you want. And similarly, many jobs. Yes, at this point we're duplicating the jobs, kind of. But this is not really a problem when you have Groovy at your hand and you can quickly generate 100 jobs from a couple lines of code. So this is roughly what we have currently in the project, and it allowed us to move very far into the surprisingly far, by the way. So the story is never ending. So future work. Development of Jenkins and scripts is kind of convoluted still in this approach, because when you do some experiments and you add and remove, you modify the protocol, you work on feature branches, then you need to say to the team, hey, watch out, I'm taking a local, very experimental feature and applying that configuration to Jenkins. So for a few moments, your job could fail because I want to run my job. This is a bit cumbersome. This is current work in progress. We're closing this experiment because, well, Dockerize Jenkins. Well, that works. Really, put your Jenkins into a container, put all the configuration, all the plugins there, and allow it to run both in the cloud as a main Jenkins and on your local computer. In that case, the thing is essentially solved. There are some quirks to that. For example, what happens with the cron jobs, like the job that will run nightly to do something with the production environment or stage environment? If you run exactly the same configuration, then you will run it twice from the master Jenkins and probably your computer Jenkins. There are details like that to be solved, but essentially this sounds like a good solution for us. Another thing, I mentioned at least twice about providing configuration, about providing information about which VPC to use, which subnet to use. We have those. We use Terraform for this because at this scale we wouldn't be able to manage that manually. So Terraform already has those informations. And with our approach, it's not that hard to use Terraform state to reinforce the input parameters. So you can remove some parameters like those subnets and just allow the provision script to just ask state, hey, Terraform state, give me the value. All right, no problem. So this is work in progress. No feedback from that yet. Common code between Jenkins and scripts in this case means that, sure, okay, we had this protocol, and I told you that for 80% of benefit, you just need to code this small snippet. If you haven't passed this environment variable, then it probably means that Jenkins broke the protocol. So let's quit early, like at the very beginning of the script, and tell the developer or DevOps engineer, oh wait, this is something wrong, the error is here, I need this value. So that covers 80% of cases, but the real solution is actually to specify that protocol once. And we're doing exactly this right now. The implementation details is to be specified, but we are considering just coding that as a Groovy script that generates, for example, bash entry point or something like that, or just using YAML or JSON files and parsing that with JQ. Both approaches seem to work. We're not sure yet which is best, so stay tuned. Single button deploys, the best feature, and we're not going to implement that because, well, it's not a priority at all. We're doing really fine with any kind of deployments and our current workload. The deployments are very simple with those fancy jobs. Sure, you have to first take the artifact, go to Jenkins, select the artifact because we have those fancy combo boxes, right? And select, okay, and there's one more thing. This is blue deployment or green deployment, so to alternate a bit. And you click deploy. This is not single button. This is more than enough. So we're not going to pursue that in near future. There's one project that we had idea of. So pipelines plugin for Jenkins is really cool because you no longer have this kind of notion of global Jenkins. You always take the code, you read okay, here's the description how to proceed, and I'll execute it at once. In JobDSL approach, it's a bit different because at your time, you say, okay, this is the configuration of the Jenkins, apply that. And in the different time, you just say, okay, use the configuration to perform some jobs. So the first approach is, of course, better. But, well, we like the JobDSL, and so we like the abilities there. And we tried to merge those approaches, and the project was getting so hacky and so hairy that we abandoned that. So maybe we should do another approach, but actually the next big step here is to remember one thing. Evolution is one thing, but sometimes you really need to prepare for a better future. So all of that stuff was coded ourselves. We coded it ourselves, and that allowed us to move quickly and deliver value. But because we delivered everything and it works nice, and we know the workload will just increase, we should probably start thinking about better approaches. Maybe Spinnaker, that will replace most of that stuff. Maybe Kubernetes even for infrastructure. Maybe some other solution. I don't know yet. So the main merit of this presentation is handle your projects well, try to think about its future, but don't forget about delivering business value on a daily basis, because that is what allows you to buy bread. Do you have any questions?
I have a question about the JobDSL.
Mm-hmm.
How do you work with code duplication? Because I can imagine you have a few microservices in a few different Git repositories, so sometimes you have to write the same job.
Yeah, okay. So, very good question. Our first approach was not to worry, and that produced quite a long file. And, well, it's still kind of manageable. But the next step that we took was to essentially take this and refactor. So what I mean is that this is still Groovy. Sure, it uses some fancy features like closures, like delegates, but there's no, actually, technically speaking, there's nothing that prevents you from using those abstractions to produce higher abstractions. In other words, you can specify, for example, the common code for all your jobs. You will specify retention period that you enable, for example, I don't know, ASCII characters to display colors on the console output of Jenkins, and you put that in single place, and then you just run. I don't know. Let's call it build. So internally, it will execute the very same JobDSL stuff, but it will return this factory job. I can't give you the exact name of the data structure right now, but you just return it, and because it's returned to you, you can use it. So, for example, for this microservice, you run the main job. It covers 50% of your cases because you just provide microservice repo if you use many repos, or subdirectory if you are approaching from the single monorepo. You just put, okay, this is the additional unique param, and that's all. For the second job, the same stuff. Use the job that covers 80% cases, just fill out the gaps. And you can go even further, like if you have, like us, the pretty and powerful jobs, you can specify that, yeah, they form a pipeline, so whatever parameters are there should be there with exception of those already specified, so the code starts to generate itself. There are many possible ways to abstract that, but essentially this is all about putting abstractions to Groovy, and Groovy is like Python. What if we wrote Python but to look like Java and work like Java? So that's Groovy. There's nothing prevents you from exploiting that. So that's programming problem, I would say.
Okay, thank you.
Thank you. Any other questions?
Have you considered using other systems, for example, TeamCity or Serena?
Yeah, but yes. So yes and no. Yes, we were thinking about that. However, we don't see much value because the same problem seems to apply to those. Of course, maybe there's some implementation detail that we missed, but it seems that the same will apply to other solutions that are hosted, like TeamCity, for example. Also, Jenkins is very powerful in terms of plugins. Just to give you a comparison, personally, I very like BuildBot. That's a solution written in Python, and you write everything in Python. This is great. However, anything fancy you want, you need to code it yourself. Maybe it's not a problem, or maybe it is. Depends on your project. For us, we decided that it's a better cost to benefit ratio. For the best ratio is for Jenkins. But there's nothing that should be probably wrong said about the other system. We never use them. The other thing here to note is that there was this blog post, I can't recall exact naming, but I think the Jenkins, TeamCity, and others were grouped as the, let's call it, fourth generation. The blog post explained that why, but the fifth generation are the solutions that are where you specified only Travis file that specifies the jobs, or any other system like that. As I mentioned, there is some problem with this approach. Some solutions like that allow you to give power back to the user that wants to perform the job, and some doesn't. For example, what if you wanted to deploy code from the Travis? Sure, you can do that. But what if you want to parameterize that to allow you to deploy this time to this region and this time to this region? That is kind of problematic. You can work around that, but this starts to we're starting to getting into the area of workarounds. There are solutions that provide this. I believe Spinnaker does that, and some other solutions probably do that too. So we're considering moving to them probably in some future, because sometimes you need to cut down and say, okay, this is all not invented here in Syndrome stuff, and we coded a lot, and that's beautiful because we love it, and we wrote that. This is our baby, but sometimes it's just better to start working on something better, even remembering the problem of Netscape.
Thank you.